So for this problem, we have to graph the function, identify the vertex as x-intercepts. So since we have to find the vertex, I'm going to write this in vertex form. So that means we're going to basically be kind of completing the square, not fully to almost to the last step. So first things first, you're going to factor out the leading coefficient or the coefficients from the first two terms. So I'm going to factor out a -4 from the first two terms. So I'm going to have f of x is equal to -4 x squared minus 2x plus something that I'm going to find, which is going to make it into a perfect square trinomial. Then I'm going to add the same thing there, or it's opposite, depends on what it is. And I'm going to add my 6 for my original equation. So the number that goes here, it's basically going to be your C or your new C that will make this a perfect square trinomial. And the way you're going to find this number is by taking your middle number here, your B, dividing it by 2 and squaring it. So we're going to have, to find our new C, we're going to have our middle number, which is our B term, divide that by 2 and square it. So we're going to get -1 squared, which is 1. So this one right there will make it a perfect square trinomial. And because we don't want to change this original equation, we're just changing the way it looks, but not actually the values. Whatever you add here, you have to subtract there. But since we factored out -4, then this means that this right here, we didn't really add a we didn't add a 1, we added a -4, because -4 times 1 is -4. So that means outside, I'm going to add a 4. If you have a -4 inside and a +4 outside, that means that's 0. So I really didn't change my original equation. So now I could factor out my perfect square trinomial. And when you factor that out, you could factor it out, or you could say, okay, the first term is x squared, so I take the square root of that, it's x. The sign of your middle term and the square root of my 1, which is 1 squared. Combine these two together and you're going to get 10. Now that right there is vertex form. And in the vertex form, now you can identify your vertex, and which is your h and your k. So this is my h, this is my k. So my vertex would be the opposite of your h, which is 1, same k, which is 10. So this is our vertex. And that takes care of the vertex part of identifying it. I'm going to graph it next. And the way I like to graph it is by using my vertex and then using the step pattern. Step pattern basically is an easy way of seeing the difference between any values that you plug in. But the step pattern is basically, you have 1, 3, 5, and there's more numbers, but we usually don't have enough room for any other numbers besides that, times your leading coefficient of A. Since my leading coefficient in this case was 4, so now I'm going to have 1 times 3 times 5 times my -4, which that means I'm going to have -4, -12, and -20. I will most likely not have enough room to graph 20 units down, but so you understand, you're always going to move to the left or to the right 1 unit, and because it's -4, you're going to go down 4. You're going to move from the other point, you're going to move 1 unit to the left and to the right, and 12 down, and 1 unit to the left and right, and 20 down. And the reason it's down because they're -20. And all of this is from your vertex. So since my vertex is 1, 10, so we're going to have 1 and 10. This is my vertex right there. And I'm going to move 1 unit to the left. So here, 1 unit to the left, and I'm going to go down 4. 1, 2, 3, 4. This is where I'm going to put a dot. And it'll be the same thing on the other side of that. So 1 unit to the right and down. And then the next one would be from that point right here, either point, you're going to go over 1 again, and you're going to now go down 12. Units 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it should be right there. That means on the other side would it be, if the original point was here, so it should be here. And then now I have enough points to sketch out my graph. And this is my quadratic graph. The last thing that I need to cover is find my x-intercepts. So to find my x-intercepts, what I'm going to do is I'm going to make my f of x of this function equal 0. Because I want to find when y's are 0, what are my x values. So I'm going to have y equals 0, which f of x is technically y. You're going to have 4x minus 1 squared plus 10. And you're going to use your algebra skills to solve for this value of x. So I'm going to have subtract 10 to both sides. Negative 10 is equal to negative 4x minus 1 squared. Divide both sides by negative 4. And if you use your calculator, you should get 2.5 is equal to x minus 1 squared. You're going to take the square root of both sides, plus or minus on that side. These go away. And if you take the square root of 2.5, that is plus or minus 1.58 approximately. And you have x minus 1. Add the 1 to both sides. And if you do that, that goes away, and you're going to have x is equal to 1 plus or minus 1.58, which that will give you your two answers. One would be 2.58. Another one will be negative 0.58 as your two x-intercepts. For this problem, they are giving you your vertex, which is your h and your k, and they're giving you a point on that graph, which is your x coordinate and your y coordinate. Since they're giving you the vertex, you should probably use the vertex form of a quadratic, which is f of x is equal to a x minus h squared plus k. You have every single value except your a, because f of x is technically a y. So when we substitute our values in there, we're going to have that f of x is a 6 is equal to a parentheses. Your x value would be 3 minus your h value, and that means your h value right here is 1, but when you substitute it in, it's going to be the opposite. So the opposite of 1 is negative 1. And then your k is negative 2. And now you're going to use your algebra skills to simplify it. So now you're going to have 6 is equal to a. 3 minus 1 is 2 squared minus 2. 6 is equal to 4a minus 2 plus 2 both sides. You're going to have 6, 7, 8 is equal to 4a. Divide both sides by 4, and you're going to get that your a value, your leading coefficient, is 2. So now that you have that, you could have your quadratic equation in vertex form would be f of x is equal to 2, that we just figured out, times, or x minus h, not h, sorry, because we know h is 1 squared and your k is 2. So this would be our quadratic function with a vertex of 1, negative 2 that passes through the point 3, 6. For this problem, they're asking you to write two quadratic functions whose x-intercepts are 2.5, 0 and negative 4.0. So these are your x-intercepts. They're on your x-axis. So we have 2.5. So we have a point here, and we have a point here. They want us to find two quadratic functions. And sometimes it's easier to see it as a graph and then translate it into an equation. And remember, we have three kinds of equations. We have standard form, vertex form, and intercept form. Since they gave us the intercepts, the nice thing to do is write it in intercept form. Once it's in intercept form, you could actually distribute and get it into standard form very easily. But if I have my intercepts, I'm going to kind of roughly sketch a graph. Most quadratics look like this. So that would be one quadratic, and I could say it would be f of x is equal to x plus 4 and x minus 2.5. Remember, it's always going to be the opposite of what's inside. The other quadratic that could be, instead of having a positive, like we discussed in class, if you just flip it around, same points, all you would have to do is multiply by a negative, which reverses our quadratic. So now it would be negative x plus the 4, x minus 2.5. And now we have our two quadratics. They have those x-intercepts. One's positive and one is negative. So for this one, we're also going to write it in vertex form. So the first thing we're going to do is we're going to factor out a negative 112. And when you factor out a negative 112, it's basically like you're multiplying. So we need to make this into a positive 1x squared. And the only way to do that is by multiplying by 12. So this becomes x squared. And now 2 times the 12 gives you a 24x. Plus something that we're going to find our new c. And we're going to add the opposite of whatever this value is, plus our original 4 from our original trinomial. We're going to get our middle term right here, and we're going to divide it by 2 and square it to find our new c. So we're going to have 12 squared, which is 144. So this is 144 right there. But technically, it's not a 144, so it's negative 112 times 144 is negative 12. So that means you're going to add a 12 outside, because this will be your special 0. That means that you already change anything. And now you're going to write it as a perfect square binomial. So now we're going to have y is equal to negative 1/12 x plus, and I made a mistake. This should be a negative right here, based on factoring out a negative 12. Sorry, guys. And that means this is a negative 12 squared. And then 12 plus 4 is 16. And if you get your vertex, you have 12, 16. This right here, your h, and that number is basically going to be your max. So how high is the ball when it is at its maximum? It is 16 feet. For the second question, it says, how high is the ball when the ball leaves the child's hand? So this is basically when it is at 0, when your x is 0. So if you have your equation and you substitute in your values of 112 times 0 squared plus 2 times 0 plus 4, you're going to get 4 feet. So this one is 4 feet. The last one is, how far from the child does the ball strike the ground? So for this question, for the last question, there's 2 ways you could do it. You could do it graphically, and you could solve this by finding the x-intercepts of the graph. I'm going to do it algebraically just because I really want you guys to work on your algebra skills. So let me make this slide smaller. And what we're going to do is we are going to make our y0. So we're going to have negative 112 x squared plus 2x plus 4. I want to get rid of the fraction in the front, so it's easier numbers to work with. So I'm going to multiply both sides by 12. And this is something we do in Math 1 to get rid of the fractions. So now our equation is going to be 0 is equal to x squared plus 24x plus 48. And I might have written something wrong. Oh, I'm going to multiply by negative 12. Sorry, because I want to get rid of it. So it should have been a negative 24 and a negative 48. I apologize. Then once I get it in this form, I could use my quadratic formula to solve this. And then my A term is 1, my B term is negative 24, and my C term is negative 48. And I'm just going to substitute into my quadratic formula that we do in Math 2, which is negative 24, which is our B, plus or minus the square root of our B, which is negative 24, square it, minus 4 times my A, which is 1, and my C, which is 48. All of that divided by your 2 times your A, which is 1. This is your quadratic formula, so hopefully you remember it. You simplify it, and I'm going to get positive 24 plus or minus the square root of 768 divided by 2. Then I'm going to have 24 plus or minus, inside of 768, there's a perfect square, so it's going to be 16 square root of 3 over 2. Since 24 and 16 are even, I could simplify this a little more, and I get 12 plus or minus the 8 square roots of 3. And to get my actual value, I'm going to use a positive value, so I'm going to focus on the 12 plus the 8 square root of 3, because the other one will give me a negative value. And I'm going to get that x is going to be 25.86 feet. That is the distance that we're looking for.